here we've got a quadratic equation.
So the first thing we want to do, you probably remember. You can tell me. Show off your impeccable memory skills. What should we do first? Yeah, okay. So we want to set this equal to 0. So basically, solving any quadratic equation, we can reduce it down to this one particular case, setting it equal to 0, or in other words, finding the zeros, right, or finding the roots, finding the x-intercepts. So, of course, we would add 5 to both sides here, right? And so that gives us x squared minus 6x. Would that 5 combine with anything? No, it's its own term. There equals 0. Now, we have two choices from here. Actually, well, we have 3. We're going to use 2 of them. All right. So 1, we could factor it. That would be choice number 1. Choice number 2, we could use the quadratic formula. Which choice is better? Who votes factoring? Factoring is better. Who votes quadratic formula? So what are some nice things about the quadratic formula? Some of you, John L., you voted quadratic formula. Why? It just works out better. Sometimes it works out better. So the quadratic formula, first off, it always works, right? It works for every quadratic. Now, some of you voted for factoring. Why'd you vote for factoring? Who raised their hand? Okay, so it's easy. At least if it factors easily. So it's easy if it's easy. So, which one's easier? Well, sometimes factoring is hard, right? Sometimes factoring is easy. So, if factoring is easy, then the factoring method is a good idea. If factoring is hard, save yourself the trouble and use the quadratic formula because you know it's going to work. Okay? Now, this one is pretty easy to factor. So let's see if we remember how to do that. So step 1, of course, is factor the left-hand side. So we're still using this same problem. So the left-hand side is right here. So would that factor? I said it was easy. Was I lying? So somebody tell me how that factors. X minus 5, x minus 1. So if you see that and it takes you about 5 seconds to do it, then factoring would be the right way to go. If it is easy to factor. But factoring is going to be hard if it's hard to factor. Right? Make sense? Too much sense? Okay, now what? I factored it. I want to set each factor equal to 0. So in other words, I'm going to have x minus 5 equals 0, or I'm going to have x minus 1 equals 0. So in other words, I have these two numbers, they're multiplied together. We call them factors. If they multiply together to get 0, that means one of those numbers has to equal 0. It's called the zero factor principle. Okay, so either the x minus 5 is 0 or the x minus 1 is 0. Otherwise, when we multiplied them together, we wouldn't get 0. We'd get some other number. So I solve each one, and I get x equals 5 and or x equals 1. So I can write my answer a couple of different ways. I can write it as a list. There are my x values. I could write it as x equals 5 and x equals 1, two separate things. But I want to make sure I show that they're both actually solutions to this equation. Okay, so that's one way to do it. Let's try it with the quadratic formula. See if we get the same thing. Hopefully we do. If not, math is a lie. Or we did something wrong. That's more likely. Okay. So, for the quadratic formula, first off, let's decide what A, B, and C are. I want to know those first before I start plugging stuff into my formula. It's going to help me out a lot if I just write them down. So take 5 seconds, write these down. So what would the A be? Remember, A is in front of the x squared. Yeah. So if there's not a number there, it's a 1. The B is in front of the x term. What's the B here? And then C would be 5. Good. Notice we don't put the x's in here. Okay? So when I'm using the quadratic formula, which I'm about to, there shouldn't be any x's in the quadratic formula. It should just be numbers. That way we can work it down to just a number. So don't put the x's with the A, B, and C. So step 2, we're going to use the quadratic formula, which I am heretofore shortening to just QF, so I don't have to write that. So we're going to use the quadratic formula. Of course, that involves us knowing what the quadratic formula is. Anybody want to sing Pop Goes the Weasel? Yes, someone actually did it. All right, thanks, Zach. So, our x values equal negative b plus or minus b squared minus 4ac all over 2a. Okay, and how many x values does this give us? Well, we've got a plus or minus, so it could be 2, right? What else could it be? Is it always going to give us 2 answers? What are the other options that we wrote down on the page before? Okay, we could also get 1 answer, and we could also get 0 answers. It depends on what happens with this guy right here, called the word just escaped from my mind. Somebody remind me what that's called. The square root, what? Discriminant. Yeah, somebody said it. The discriminants. This is how you, at least someone said enough of the letters that it popped into my brain. So this is how you discriminate the number of solutions from this part right here. Okay, so let's try it. We're going to plug in numbers. So everywhere I see a B, I'm going to put a negative 6. So this is negative B. That's negative 6. Okay. So everywhere I see a B, I'm going to put that negative 6, plus or minus the square root. So negative B squared, that's negative 6 squared. Right now I'm just going to plug in the numbers. Everywhere I plug in a number, I'm going to put it in parentheses because that's going to help me stay organized. Here I've got 4 times A, which is 1, times C, which is 5. Okay. All over 2 times A, which is 1. So there it is, my quadratic formula. Now all we have to do is simplify it. Does it look like a lot of trouble? It shouldn't be, because we know we're going to get nice, pretty answers from the left-hand side, what we did over here. So, let's see what happens. So step 3, simplify. And first, we're going to start with the discriminant. That's the square root part. Okay. So what happens underneath the square root? Let's get that taken care of first. Alright, so what's negative 6 squared, Ethan? 36. Okay. And I'm going to jot myself some notes up here. And then 4 times 1 times 5. What's that, Caitlin? Yeah. And it'll be negative because we've got a minus in front. So it's 36 minus 20. By the way, while I'm writing this down, what's negative negative 6? I'll go ahead and take care of that while we're here. So what's under the square root? Yeah, 36 minus 20, which is 16. And on the bottom, 2 times 1 is just 2. Now, I'm not quite done simplifying the square root part because, of course, 16 has a square root. What is it? So it has a square root of 4. So that's 6 plus or minus 4 divided by 2. Now I'm going to split this up into 2 separate answers. So we have 2 different answers here. So step 4. Step 4, split it up. Alright? So split up the, I'll say the plus or minus. So one of my answers is going to be the plus, so 6 plus 4 over 2. And the other one of my answers is going to be 6 minus 4 over 2. Okay? So I'm going to split it up into 2 separate possibilities. Let's see. So 6 plus 4 minus 2, what does that give us? Yeah, that's 10 over 2, 5. And 6 minus 4, that's 2 divided by 2. What? Question? 6 minus 4 divided by 2? So, we simplified the square root part, which gave us 16 under the square root, right? Then took the square root of 16, which is 4. And then, yeah. Cool. So, our roots are 5 and 1. So we solved that equation. Okay? And we solved it 2 different ways, and we got the same thing both times, which is a good sign that it's probably correct. Alright. So hopefully you've seen these things before. I know you have. In Algebra 1, and then again in Algebra 2. And it was really fun both times. It's still really fun. So I'm not going to work through more examples of those. I'm going to let you work through some examples of those here in a few minutes. Because I don't think you need to watch me do it again. Hopefully that's enough of a reminder. You just need to practice a little bit so that you'll be good at it when we go on to the next day, which is solving bigger equations, cubic equations, 4th power equations, etc., etc. So, one more thing we want to talk about. A different kind of example. Let me start over. So I want you to give a quadratic function that has roots as follows. So one of the roots, that's an R, R1, is, let's say, 1. The other root is -1. Okay. And it passes through the points let's say -2, 4. Yeah, we'll go with that. Okay. So this time we know what the roots are, and instead of trying to solve for the roots from the equation, we're going to do the exact opposite. We're going to take the roots and try to write the equation of that function. So in other words, I know that my function looks like this. And it goes through the point -2, 4. So I want to know what function is that. Okay. So, because I know the roots, let's try and work backwards here. So let's look at what we did on the page before. Because I know the roots, I might be able to use the roots to write the factors, right? Let's say I solve this by factoring. So what factors would have given me, here we would say, what factors would have given me roots of 5 and 1? Well, if I take x equals 5 and I move the 5 over to make it 0, I get x minus 5, right? Or if I take, well, it's not quite that easy. In this case it is, yeah. Or if I take x equals 1, I can move the 1 over and I get x minus 1 equals 0. So those would be my two factors. Okay, so what factors would give me, or what factor would give me a root of 1? Yeah. So the first root is 1. That means I'm going to have x minus 1. And then the other root is 2. That means I'm going to have, is -1. That means what factor would give me a, what factor would give me a 0 of -1? Yeah, that would be x plus 1. Okay. Or in other words, let's go back to our factored form that we talked about on the very first page of a quadratic equation. So essentially what we're doing is we're filling this in right here. So our function is going to look like this. If I have the roots R1 and R2, or whatever I want to call them, I just picked R because that's the letter that root starts with. If we have those two numbers, we can write out our equation like this. So our function is a times x minus the first root times x minus the second root. Okay? And so let's think about it this way. So here's my function. Now, do I know what this value of a is yet? No, I'm not sure. But I know what my roots are. So x minus, so my first root was 1, right? So I'll put a 1 there. And then x minus, and my second root was -1. Okay? So I can think about it intuitively like this, like we tried to up here, or I can just use the formula. Plug in the two roots. There's a root. There's a root. But hopefully it makes sense why we're subtracting the roots. It's because you would change the sign if you tried to set it equal to 0. Okay. So we get a times x minus 1 times x plus 1. Now, how do we find a? So this could be an infinite number of different quadratic formulas. It could be 2 times x minus 1 times x plus 1, or 7 times x minus 1 times x plus 1. They would all have the same roots. Well, what would multiplying by a number a out in front do to our function? What does multiplying by a number out in front do to any function? Yeah, it's a vertical stretch. So we could have a parabola that goes through these two x-intercepts right here, but it could be stretched out. It could be really short and squatty, so it could be vertically squashed. It could look a lot of different ways and still go through those 2 points. So it's this value a right here that's going to tell us how vertically stretched our function is. And so to get it vertically stretched the correct amount, we want to make sure that it goes through this point, -2, 4. Okay, so we're going to find the proper value of a using the point that we have. So we know our parabola goes through the point -2, 4. Okay, just because that's what the problem said. Alright. So the -2, of course, is going to be the x value. And then the 4 is going to be the y value. But I'm going to call it f of x, because we're dealing with a function. Okay. So now we're going to substitute these values into the function. Substitute, yeah, these into the function. Which function? The one we're talking about, f of x. All right. So what am I gonna plug in for f of x? Yeah, I'm gonna plug in the 4. So 4 equals, what am I gonna plug in for a? Nothing, because I don't know what a is. That's what I'm trying to figure out. What am I gonna plug in for x? Yeah, so -2 minus 1 here, and then for x I'm gonna plug in -2 again. I want to plug it in both places. It's not -2 times x. I'm replacing x with -2. I'm substituting. And so we're going to solve for a. First, let's figure out what each of these simplifies to. So what's -2 minus 1? That's -3 and then -1, right? So then 4 equals how many a's? What's that? So, yeah, so 3 times a. And then one last step. Divide by 3. So a must equal what? 4/3. Okay. So in other words, our function would be, so we're going to take that a, we're going to take this value for a and plug that into the function. So we're going to plug in a now. But we're going to leave x and y as variables. So our function is 4/3 times x minus 1 times x plus 1. Thank you, sir. Oh, I thought it was for me. Okay, so this is one way we could write the function. This is in factored form. Let's try to expand this into standard form. So remember, standard form is as a list of terms. Okay, so we need to be able to have this written both ways depending on what it is we're trying to do. So let's expand this into standard form. I didn't ask for it specifically in the problem, but I could. And because I'm out of room, I'm going to go to the next page. So let's expand this to standard form on the next page. Alright, so I'm going to start with my function. It was 4/3 x minus 1 times x plus 1. So, what should we do first? It doesn't really matter, but one thing we don't want to do that I saw a handful of us do on the test was take this 4/3, or whatever number's out there, and distribute it to the x minus 1, and then distribute it to the x plus 1. That's not how multiplication works. Just pick two things and multiply those two things together. I'm going to start by multiplying the x minus 1 times the x plus 1. But you could start by multiplying the 4/3 by the x minus 1, or any other two things. So I'm going to multiply these together first, only because I feel like it. It doesn't matter. So 4/3 times what? X squared. And this is a difference of squares, so I get plus x and minus x, so those cancel. And that leaves me with negative 1. Okay. So that's after my foiling. Or, if you're paying attention, you can use the difference of squares shortcut. And I don't quite have a list of terms yet. I still have some multiplication, some parentheses in there. So I'm going to write that. I'm going to distribute my 4/3. So it's going to be 4/3 x squared minus 4/3 times 1, which would be 4/3. So here's my function in standard form. Okay, and because it's in standard form, I should be able to see my A, my B, and my C. So what would my A be in this case? 4/3. That's the number that's in front of the x squared. What would my B be? Yeah, there's not an x term, right? So there are exactly 0 x's. So we put a 0 in there for the missing term. And then this negative 4/3 would be the C term. Okay, so that's standard form. I've got my A, my B, and my C there, and those are useful for other things. All right, so those are the basic quadratic skills that I want you to have. Be able to solve an equation two different ways. Be able to take the roots and write the equation from the roots. So those are two basically inverse things that you can do. Take an equation, find its roots, or take the roots, find the equation. One is the opposite of the other. Okay. So all you really need to do is practice some. You don't need to watch me do anymore. You need to do them yourself. So let's start with, well, I don't know. Let's start with this factoring part right here, since factoring should be pretty fresh in your mind from the test last week. So let's see if we can get these factoring problems done today. And then tomorrow we'll work a little bit on these others. So remember, first, set everything equal to 0. So set everything equal to 0 first. And what's always a good first thing to look for when you factor? Yeah, first we should look for common factors. So move everything to one side so that it's set equal to 0. Then before you start trying to factor it out, first look for common factors. That's a good starting place. And then go from there. Okay? Go.